You are welcome back to our series on these shapes, areas and perimeters of shapes and properties of a circle. Now we're talking about the area of a segment, as you can see. How do we get a segment from a circle? If you have a circle and you have this, like I've said before, this is a shaded region, this is a minor segment, and this, here you just have this done here. This is a bigger part. It is a major. It's a major segment. Why this is a minor segment. So all in all, they are both segments. So if you are given a question and you are told to calculate the area of that segment, we've done the perimeter of a segment where we consider the perimeter of a segment. Look at this segment. It is having a length of arc L. It is having length AB, the length of a chord, which is AB. So this region is what we need. So which means the perimeter of this segment, the perimeter of this segment, oh, I need something, okay, yeah. The perimeter of this segment, which is this, that looks like a semicircle, but it's not a semicircle. You need this place. You need this place. It is what to be the length of the sector, or the length of this chord AB plus the length of the arc. That will give you the perimeter of the segment. Now, when you now have the area of the segment, you consider the what? There are two things you're going to consider when you are calculating the area of a segment. One, the area of a sector. Most of the time, there will always be a sector drawn for you. Let me redraw this. I have something like this. If you don't have, you form a sector out of the circle. So you have this, have this, have this, have this. So you are looking for the area of this place. Yes. And this is a sector on its own. Radius, radius is a sector. So you need the area of this whole sector. The area of this whole sector. Then what do you do from it? You subtract the area of this triangle. You subtract the area of the triangle. What you have left will be this region. And that will be the area of that segment. So what does that say? Area of segment be equal to what? The area of a sector, which is theta upon 360, times what? Times pi r square minus the area of this triangle. This is RR. There will be a theta here. So what does that mean? Let me clear this. Then I drew in here. There will be a theta here. So this will be like a what? An isosceles triangle, or a triangle such that two sides are only given. And what's the formula for calculating the area of such triangle? It is 1 upon 2 half AB sine theta, where A and B will be your two radii. Your radii, that will be R squared sine theta. Is that noted? So we go. We have this. We have this. Oh, let me rewrite something here. Yes, I need to rewrite this. Oh, sorry. So you have this. Don't mind this. 。  . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 . 。 . 。 . 。 Yes, it should look like this, such that you are going to be having it look like a sector, and the length, this should be sharp. So you have something like this. How do you calculate the length, the area of the shaded segment of the circle? You pick the whole of this, it looks like a sector, right? Then you remove this triangle. This is, let me name it. You have A, you have A, you have B, you have C. So consider the whole sector. Consider the whole shape as a sector. This is a sector. This is how it looks like. So this is how it looks like. This is a sector on its own. It has this place to be 63. And this is 10. This is 10. So this is a sector. So area of a sector, area of a segment which we are calculating, let's go with that. Area of segment, this is a segment. This shaded region is a segment. When you calculate the area of the O shape, which is the area of a sector, which will be 63 upon 360 times, what do we have? We have pi r squared, being given pi to be 20 over 7 times 10 times 10, then minus 1 over 2 times 10 times 10, then times sine of that angle, which is sine 63. So you have sine 63 there. Let me write that down. Sine 63. So let me continue from here. Sorry about that. So what do we have here? Let me multiply straight up so that we could just have a value, then we. So I note the area of the segment to be A. So let me continue with this. Okay, I have this 63 times 22, 63 times 22 times 100. I will go to 138, 138, 138,600 divided by, you have 360 times 7, 2,520, and minus the half of this 2-year 1. You have your 2-year 1. 10 should have been written here, then this should have been 5. That will be 50 times sine 63. Sine 63, you got this, then times 50. 44.55. I have 44.55. Permit me to write it there. So what do we have eventually? Our area will be equal to 138,600 divided by 2,520 520, that will become 55. 55 minus 44.55. So we have our answer to be 10.45 is in what? Centimeter square. Thank you for joining me. We'll see you again in the other work.